Hi guys, greetings of the day. This is Vardhan. Welcome to my YouTube channel for learning a subject called as Fluid Power Engineering for 5th semester and Fluid Power Systems for 7th semester as per video syllabus. If you haven't subscribed to my YouTube channel yet, kindly subscribe. Also click on the bell icon to receive the latest lectures as and when it is uploaded in my YouTube channel. Now let's start the session number 6 for the subject. In this session, we are going to have a discussion on the seals, sealing materials, compatibility of seals with the fluids. One of the most common problem associated with the fluid system, either it is a hydraulic system or pneumatic system, is a leakage. Leakage results in loss of fluid power and reduction in the efficiency. This needs to be seriously dealt with to keep the system running at its optimum efficiency. Lot of precautions has to be exercised at the design stage itself to make the system leakage free. However, it is very difficult to design an absolutely leak proof system because the physical nature of construction of the fluid power elements and their susceptibility to wear and tear with the usage ultimately resulting in leakage. The problem of leakage can overcome to some extent by proper maintenance of the system and proper selection of seals and sealing at the design stage. This means that seals and the sealing plays a vital role in preventing leakage. Leakage in hydraulic system could be either internal or external in nature. And the figure shows the internal leakage where the internal leakage portion is being highlighted. Internal leakage occurs in hydraulic components built with operating clearances. Moving parts need to be lubricated and leakage path may be designed solely for this purpose. Internal leakage does not cause loss of fluid. The fluid intact is returned to the tank. Internal leakage increases the wear of the component resulting in loss of power and reduction in efficiency of the system, slowing down the work and generating the heat. If the internal leakage path becomes too large, then the complete output of the pump is drained off without any work. Then coming to external leakage, which is identified in the figure. External leakage is unsightly, can be hazardous. This leakage is due to improper installation. Leakage through joints may be due to a shock or vibration, which will loosen them, and the failure to connect the drain lines, excessive operating pressure, and the contamination in the fluid are some of the common reasons for external leakage. External leakage leads to the loss of fluid, which will increase the cost of operation of the hydraulic system. Thus, the leakage could be prevented effectively by using the proper seals with the correct specification and application. Then, we need to understand what are the functions of the seal. The primary function, and it goes on like that, prevent leakage of both internal and external in nature, and it should prevent the dust and other particles entering into the system, and it should maintain the pressure, and it should enhance the service life and the reliability of the hydraulic system and its elements over a long service period. Then coming to the classification of hydraulic seals are broadly classified based on the following factors. The first factor is called as method of sealing, which can be further classified into positive and non-positive types of sealing. And what is called as a positive seal? A positive seal, even a minute amount of oil is getting the pass. And what is called as non-positive seal? A seal allows a small amount of internal leakage, such as the clearance of the spool in the pore, providing the lubricating. Then coming to the relative motion exists between the seal and other parts, we can call it as a static seal and dynamic seal. And what is called a static seal? A seal that is compressed between the two rigidly connected parts is called as static seal. And there may be a movement within the seal due to variation of pressure, but the mating parts do not move in relation to each other. Example of static seals are a pipe threaded connections, flange joint seals, O-rings, etc. Static sealing applications are relatively simple. They are essentially non-wearing and usually trouble-free if assembled properly. Then coming to dynamic seal, Dynamic seals are installed between the parts which move relative to one another. Thus, at least one part rubs against the other, and seals therefore are subjected to wear. Generally, they find their applications in reciprocating or rotary systems, where speeds are not too high and good heat dissipation is possible. Then coming to geometrical shape, based on the shape, we can classify it as O, T, V, and U. We are going to discuss in detail about it. And also the sealing material, neoprene, nitrile, Teflon, silicon, etc. We are going to discuss in detail. Now, let us have a classification based on the geometry in detail as we told. We are going to discuss the first type of seal is called as O seal. Now, O seal ring is called as O seal because the cross section of the ring is called the shape of the alphabet O. Probably O ring is the most commonly used static seal. It comprises of a molded synthetic ring with the help of a round shape when unloaded. O-rings can be specified in terms of inside diameter for fitting on the shafts or outside diameter for fitting into the bores, which is as shown in the figure. O-ring is compressed in one direction when installed. Application of pressure causes the ring to be compressed at right angles to give the positive seal against the two annular surfaces and one flat surface. O-rings give effective sealing at a very high pressures. Primarily, O-rings are used as a static seal because any movement will cause the seal to rotate, causing leakage. Then coming to T-seal. T-seal rings are dynamic seals extensively used to seal cylinder pistons, piston rods, and other reciprocating parts. It is constructed of synthetic rubber molded in the shape of the cross-section T and reinforced by backing up the rings on either side as shown in the figure. The sealing edge is rounded and the seals very much like an O-ring. Then coming to V-ring and U-ring. The V and U ring seals are compression types seals and used virtually in all types of reciprocating motion applications. And this includes piston rods and piston seals in pneumatic and hydraulic cylinder, press rams, jacks, and seals on plungers and piston in reciprocating pumps. They are readily suited to certain slow rotary applications such as wall stumps, etc. Then coming to the different types of sealing material, the classification. The seals are manufactured from a variety of natural and synthetic materials. The choice depending on the fluid used, operating pressure and temperature. The leather, cork, and integrated fibers were the earliest sealing materials for hydraulic equipment, but these have been largely suppressed by the use of plastic and synthetic rubber materials. Natural rubber materials cannot be used in hydraulic system as it tends to swell and perish in the presence of oil. And the synthetic rubber, which is also called as elastomers, however, are the most part of compatible with the oil. Elastomers can be made in various compositions to meet various conditions, operating conditions. The different elastomers used in the material are, first one is called as neoprene. Neoprene is one of the earliest elastomers used in sealing material, a tough material with the limited temperature range up to 65 degree centigrade is still using in almost most of the systems. Then come to nitrile, which is also called as Buna Yen, and nitrile is one of the widely used sealing material in modern hydraulic systems and has a wider range of operating temperature between -50 to plus 100 degrees centigrade, and currently the cheapest seal material. It is moderately tough, inexpensive, and at moderately high temperatures it remains in its shape in the most of the petroleum fluids but swell in some of the synthetic. Coming to the next one, which is called as silicon or a Teflon. This elastomer has a wide range of temperature than the nitrile, ranging between -100 degrees centigrade and 250 degrees centigrade, and is therefore a popular material for rotating shaft seals and systems that run from very cold to very hot. At higher temperature, silicone tends to absorb oil and swell. Silicone seals are compatible with most fluids, even more so fire resistant fluid petroleum. Silicone is not used for reciprocating seals because it tears and abrades too easily. Then coming to the another type of seal material, which is made up of a plastic. Either it could be called as a fluoroplastics, as well as one more type is called as fluoroelastics. Several sealing materials are synthesized by combining fluoride with the elastomer or a plastic. They include KLF, Vitan A, and Teflon. Nylon is another synthetic material with the similar properties. It is often used in combination with the elastomers to give them reinforcement. Both nylon and Teflon are used as backup rings as well as sealing materials. All these have high resistance up to 300 degrees centigrade to heat the compatible with the most fluids. Then compatibility of the seal with the fluids we need to discuss. In a fluid power systems, the fluid compatibility is often discussed with respect to seals. Compressibility of seal with the fluid centers the pictures as a final arbiter of which seals and components can be used with certain fluid. For example, natural rubber is not oil resistance and should not be used in hydraulic system using petroleum oils. And synthetic rubbers vary widely in their behavior when exposed to different fluids in contact with the given fluid. Some are unaffected, but others swell, shrink, or otherwise deteriorate. Most oil seals in contact with the oil are made from nitrile rubbers. Other materials suitable for oil system include neoprene, silicones, and fluorocarbon rubbers. Most tubing and fitting manufacturers present extensive tables of materials compatible with their product specification. Now, this is the end of the session 5. Thanks for your patience listening to the session. If you have any sort of doubts, feel free to use the comment section for further discussion. I will answer all your questions related to the topics covered in this session. Don't forget to like, share, and subscribe. Have a great day. Signing off, Vijay Tavardhan.